We all on page 13? Okay, so the other test is called a chi-square test for independence. Now, what does it mean if two variables have an association?
Knowing one can help you predict the outcome of the others.
Right. Knowing the likelihood of one event affects likelihood of another. So two variables can have an association. That means that they are dependent. Do you remember in probability how to test for two variables being independent or dependent? Alex?
Probability of A given B equals probability of A and B divided by probability of B.
I agreed with this part. That always works for every conditional probability. Now, remember what this is saying. Would you like to change what you just said? Brandon?
Probability of A given B equals probability of A.
Correct. Right, because knowing B didn't affect the probability of A. Now, you're not going to use that, but it's just good to know. How do you state the hypotheses? The null, you're going to say that blank and blank, so whatever your two variables are independent. Sometimes you will also see that they have no association. So sometimes people use the word independent, sometimes they use the word associated. But basically, you're assuming that your two variables don't have a relationship. And then you're looking for evidence to the contrary. This is perhaps the most important thing that we are going to talk about today, is when to use a test for independence, when to use a test for homogeneity. So first thing you need to know is that both start with a two-way table. So just by looking at the data, you're not going to be able to tell. Okay, test for, well, let's do homogeneity first. Test for homogeneity. You have two or more samples or treatments and only one variable of interest. So the example that we did in class, your two or more samples or treatments was the color of the surveys. Then all we cared about, our only variable, is what color candy people were taking. Test for independence, you have a single sample, and then you have two or more variables. So the biggest indicator that's going to help you choose what test to use is how the data is collected. So was the data collected from a single sample and then people were asked multiple questions? Or were there multiple groups of people surveyed that were only asked a single question? How do you calculate the expected counts, the test statistic degrees of freedom? Exactly the same as a test for homogeneity. Conditions are mostly the same. Here's the one difference. What is the first assumption always? Okay, so in the context of a test for homogeneity, it could be an experiment, in which case you're looking at whether you have randomized treatments. What if it's a survey or an observational study? What does random mean? Kyle?
The people selected were randomly chosen.
Right, you have random samples, plural, because you have multiple samples. In a test for independence, you're not going to have treatments. You just want to know, is it a random sample, singular? There's only one sample. So for homogeneity, it's going to say random samples, because you're going to have multiple samples. But in a test for independence, you're only going to have one sample. Okay. Ready for an example? We're going to do the example on the next page, page 14. Is your index finger longer than your ring finger? Is relative finger length associated with gender? A random sample of 460 high school students in the U.S. was selected and asked to record if their pointer finger was longer than, shorter than, or the same length as their ring finger on their left hand. The gender of each student was also reported. Do the data provide convincing evidence at the alpha equals 0.05 level of an association between gender and relative finger length for high school students in the U.S.? Okay, so a few things to point out. First of all, the question says, is there an association? That does not mean that this is a test for independence. So please don't look at the wording and assume that that's exactly what kind of test it is. It's a two-way table, just like we did on Friday for homogeneity. So we need to look at how was the data collected. So do we have one sample, or do we have multiple samples or multiple treatments? Single sample, one sample of 460 high school students. So we looked at a bunch of high school students and then recorded two pieces of information: finger length, gender. So we have one sample, two variables. That tells us this is a test for independence. Mainly that one sample part. So the fact that we only have a single sample means that this is a test for independence. I'm going to do the state step with you. You are going to do the rest of it. So for the state step, I'm going to conduct an upper-tailed, remember chi-squared is always upper-tailed. It's called a chi-square test for independence. Again, you also might hear association. So a chi-square test for independence. How many degrees of freedom will we be using? 2. So number of rows minus 1, number of columns minus 1. Multiply them. So using 2 degrees of freedom, and alpha is 0.05. We are going to test the following hypotheses. Okay, the wording of the null and the alternative are a little bit different. So for the null, we're going to say relative finger length. So that's the first variable. And gender are independent. So this is exactly what I had on the previous page. That's variable 1, that's variable 2. We're assuming that there's no relationship. Instead of independent, you can say not associated. Please do not write both. Pick one or the other. I don't want to see both every time. So then your alternative is that relative finger length and gender are dependent. Okay, the rest of this test is exactly the same as how you would carry it out for a test for homogeneity. So you have 10 minutes to finish this with the person next to you.